Hello everyone, this is your favorite Pankaj sir. We are going to start a new chapter. So basically, we are going to start the article today, that is calorimetry. So let's begin. Okay, so we are going to start calorimetry. Let's start. If I say what is calorimetry, calorimetry. What is calorimetry? If I say what is calorimetry, so that is basically study of heat, and we are going to study about heat, and we are going to discuss over here only about liquids and solids. In this chapter we are going to discuss about liquid and solid. Means we are going to study about if the heat is given to liquid and solid, then what will happen. Basically we are going to start to basically, if we want to start this chapter, we have to start with some important terminology. So we are starting with some important terminologies. Okay, we are going to start with important terminologies. So first of all, we are going to start one by one. So our first terminology is specific heat capacity. This is also represented as S, and if we say specific heat, both are the same thing. If it is written like this, that is also the same thing. Okay, specific heat or specific heat capacity, both are same thing. So we are going to state about this thing. Okay, this is denoted by a symbol small s. Okay, so let's begin. If I say this is our substance, if we supply the heat over here, delta q is supplied to this substance. If I say delta q is supplied to this substance having mass m, and the temperature changes from T to T plus delta T. If I say, then T to T plus delta T, then specific heat, if I say specific heat, that is defined as heat given divided by mass multiplied by change in temperature. It is also written mathematically like this. This is a heat supplied per unit mass per unit rise in temperature. If I say the unit of this specific heat unit will be, if I say SI unit, then SI unit will be joule per kg Kelvin, or we can also written it like joule kg per degree Celsius, because change in temperature in Kelvin and degree Celsius both are same. Or if I say general unit, so general unit, that is also used like calorie per gram degree Celsius, or kilocalorie per kg degree Celsius, like this. I will explain it to you. These are the units that can be used. Right now you just have to see the units that are used. This is our first definition, that is for specific heat capacity, denoted as S. We can say like this: if we take 1 kg of substance and we want to increase the temperature by 1 degree Celsius, then the heat required will be basically the specific heat. So we are going to talk about next thing. Okay, so this is the specific heat. We can note it down like this. If I say delta Q can be also written as like ms delta T. I have just multiplied this m delta T with s, so we have get some formula for this delta Q. So that is coming to, okay, this is our formula. Okay, so basically I'm just doing a small problem so you can understand better. If I say, I'm taking some example. Okay, if I say there is a object, mass is given as 2 kg. Okay, if I say mass is given as 2 kg, and if we supply some heat, if I say the heat supplied is 200 joule, and its temperature is increased from I say 25 degrees Celsius to 26 degrees Celsius. Okay, 26 degrees Celsius. If I say temperature is T initial to T final, that is 25 degrees Celsius to 26 degrees Celsius. Question is find the specific heat. Okay, so if I say the specific heat calculation, then we can do by the formula, that is simple. If I say what is the formula solution, if I say that specific heat is simply delta Q divided by m delta T. So basically the heat supplied is 200 joule and the mass is 2 kg, and the change in temperature is if I say 26 and 25, if we subtract, then we will get 1 degree Celsius. Basically we are getting like this: 100 joule per kg degree Celsius. This will be our answer for the given problem. If I say the similar question, if I say we have this object having mass, if I don't know how much heat is supplied over here, we have to calculate the how much heat is supplied over here, given that specific heat capacity is given to us as uh, 2 kilojoule per kg degree Celsius. Like this it is given. It is said that we have to increase its temperature T initial to T final, that is 20 degrees Celsius to 30 degrees Celsius. So the question is asked is over here: find the heat required to do so. So basically how much heat is required to raise its temperature from 20 to 30, this is asked to us. So basically what we will do, we will write down the formula, that is ms delta T. So basically we have to put over here, you can see the all the units are not SI, so we have to write down the values as well as units. So mass, if I say the mass is given is 2 kg is given to us. Okay, so 2 kg multiply by specific heat capacity, that is 2 kilojoule per kg degrees Celsius, and the change in temperature is basically 10 degrees Celsius. So this degree Celsius and degree Celsius will cancel out, this kg and kg will cancel out. So basically we are getting, as a result, as delta Q, we are getting as, this is a 40 kilojoule, we are getting 40 kilojoule we are getting as our result. Okay, so basically if the specific heat is given to us, so we can apply these formulas, get our results. We are going to discuss some problem over here. Okay, so it is like this. I am just telling the next topic, that is the law of mixing. I am telling. Okay, this is like we are mixing two things. Okay, like if we take a container, here some liquid is there with some temperature, it is mixed with some other liquid that is having some temperature, then what will the final temperature? This is likewise. So I am just discussing the problem so you can better understand what I am saying. Let's see. I am saying we have a container, we have a container. Okay, we have a container, we are mixing two things. One thing, like we are saying we have a substance A and we have a substance B. We are mixing both the things in a container. We are saying it is given the specific heat of A is SA and temperature is TA and the mass is MA. And for this I am saying the temperature of B is given as TB and SB and MA, like this. If I say what will the final temperature, it is given that TA is greater than TB, it is given. Okay, so what will the final temperature we are asking? So to do this thing we have two methods. I am discussing the first method, that is we can say that the energy of the system will be conserved, means how much energy will be lost by A, because the temperature of A is more and temperature of B is less. So the temperature lost by, the energy lost by A will be gained by B. So we can say energy lost by A equals to energy, equals to will be energy gained by B. So how much energy will be gained? So we can write it like this: MA SA T final. If I say the final temperature, if I say final temperature, T will be question mark. So we are assuming the final temperature will be T. So the energy lost by A can be written as TA minus T, and energy gained by this B can be written as MBSB multiplied by T minus TB. This is like this. So if I multiply the things, then we are getting MASATA minus MASAT equals to MBSBT minus MBSBTB. So if I just transfer these things, then we are getting MASATA plus MBSBTB equals to MASA plus MBSB multiplied by T. I'm taking the T as common, and we are getting the temperature as M A S A T A, like this. M A S A T A plus M B S B T B divided by M A S A M A S A plus M B S B. This is our final answer. I personally don't like this method because if we take the three substance, so we can't decide which is gaining and which is losing the heat. So basically, I like the method 2, that is more good than this, because we don't have to care about the which is gaining the energy and which is losing the energy. Just discuss the method 2, then you will understand why the method 2 is better than that. So I am just taking this method 2. In this method 2, we will assume that all the substances are gaining heat. I'm just assuming gaining heat. We are assuming. So the T final will be always higher. This is, we can say the T final will be always higher. What is, so we will say summation of all the heat gained, that should be equals to 0 likewise. So how we will write this thing? So we can write MASA. We will assume the T final will be always greater. So T minus TA plus MBSB T minus TB equals to 0, like this. And if we calculate the answer, we are getting as T equals to MASA T plus MASB TB divided by MASA plus MBSB, like this. I'm just generalizing the equation so you can remember this thing. Okay, so I'm just taking three substance, and after that I will generalize the whole formula. Okay, MB and SP. So basically I'm taking the another question like this. Same to same question is there. We have a container. Okay, we have a container and we are mixing now three things. Okay, we are mixing now three things, similar things, like this: 1, 2 and 3. We are mixing three things having masses MC, SC and temperature TC, and this is having mass MAS A or TA, and we have another mass that is MB, SB and TB, like this. And I am assuming that find the final temperature T, that is the thing we are having, we have to calculate. So find the final temperature capital T. This is the thing what we have to require to calculate. So what will be the answer? Let's see. How to do? We will say the net heat gain by all will be 0. So I'm writing the heat gains of each substance. So we can say MASA T minus TA plus MBSB T minus TB equals to plus MCSC T minus TC should be equals to MC. So if I multiply, then we will get the result as M A S A T A plus M B S B T B plus M C S C T C divided by M A S A plus M B S B plus M C S C. That is the formula we are getting. If you, this is the formula we are getting. Okay, if you want to remember, you can remember, but I prefer to solve the question because the concepts are important. Okay, that is the formula we are getting. Now we are to discuss the next terminology, that is we are going to discuss the next terminology is heat capacity. That is heat capacity. If I represent this, then this is represented by C. What is the definition? If I say this is the some substance and some heat is provided to this substance. If I say delta Q heat is provided and its temperature is rises from T to T plus delta T, then heat capacity is written like this: delta Q divided by delta T. This is the simple expression. So we can also define it like this. We can define like this. That is heat required to raise temperature of a substance by unity is called heat capacity of that substance. Okay, so if you remember the formula of delta Q, what we have studied just before, that is delta Q is written as ms delta T. So basically this delta T and delta T will cancel out, and we are getting a formula like C equals to ms. This is also useful if we require, then we can remember this thing, C equals to ms. Okay, if I say a note point that we can remember, if I say we are taking three substances like this. First substance is 1 kg water, second is a 2 kg water, and if I take third substance, that is 3 kg water. If I say which one have, if I say the question, all three are water. Okay, this is our first sample, this is our second sample, this is our third sample. Okay, and this is 2 kg and this is 3 kg. If I say what is the specific heat capacity of first, second and third, so what we can say, if I say which sample have largest specific heat capacity. So basically this heat capacity, specific heat capacity, if I say specific heat capacity, this is the property of a material. So this depends only on material. If material is same, then specific heat capacity will be same. This is depends on type of material. So basically, if I say which sample have largest heat capacity, so then the answer will be all have equal heat capacity. So you can remember this thing.